Java. In Java, this is a reference variable that refers to the current object. If there is an ambiguity between instance variable and parameter variable, this keyword resolves the problem of ambiguity. Let us understand with the help of this example. Here, account is our class, having attributes account ID and account balance. Account class will have behaviors, or methods also. We can deposit amount in an account, or withdraw amount from account. We can also see the balance of our account. We have created 3 objects of class account, with different values of attributes. All these 3 account objects are having different IDs and balance. Their behavior will be same, but effect of this behavior may change value of attributes. We will have a constructor to initialize values of all attributes for different account objects. Now when we are instantiating given class, or calling getter-setters of account class, it is difficult to know that currently which account is in process. In such a scenario, we can refer to current object of account, which is in process of using this keyword. Let us consider this example, consisting of 2 Java files. In first Java file, account.java, we have a parameterized constructor and getters or setters. We have methods for deposit and withdraw in the same class. Next, we have added one more method, display balance, to display account information. As you can see, we have used this keyword repeatedly. It becomes mandatory to use this with the instance variable, if behavior and/or constructor has parameter, with same name as class instance variables. As we can see in the code at line 8 and line 9, we have an attribute and parameter with same names. This keyword helps us to differentiate between both of them. This keyword will refer to the attribute of current object in process, while another variable with same name refers to the local parameter variable. Now let us observe another Java file, testaccount.java. Here, we are instantiating objects of account class. So when constructor is called for account1 object, at that point, this keyword in constructor of account.java file refers to account1 object. Similarly, while creating object account2, this keyword refers to account2 object and so on. Note that, we are calling display method using instance, account1 and account2. So when we call display method, information of respective account object, that is, account1 or account2, by which method is called, will be displayed. If we execute given code, we can see following output. And, if we execute given code by removing this keyword from account.java file, we will get following output. As we noticed, account number is displayed as 0, and the amount is displayed as calculated on 0 value. The difference is visible, because when we don't use this keyword in the constructor, the initialization of instance variables does not happen at all. That is, if we write the constructor like this, then, here at line 8, both sides will refer to the parameter variable, account ID only. Similar behavior will happen for line 9, account balance as well. Thus, the instance variables of the class get initialized to the default value only, and not to the value which was passed to the constructor. We discussed about how to access attributes when there is same name for parameters and attributes of an object. Now, observe figure 1. We can see that the account ID is a sequential 1-digit number for all 3 different account class, that is, account1 object possesses ID 1, account2 object possesses ID 2, and account3 object possesses ID 3. Now let us add one more object, account 4. Hence, the account ID of this object will be 4. What if we want to create a large number of account objects? It is difficult to track and assign sequential number to account IDs for all different account objects every single time. So, in such cases static can help us. Let's make one small change in this code. As we can observe in this code, account.java, we made counter as static. In the constructor, instead of initializing account ID from parameter value, we are incrementing counter and assigning its value to account ID. Here, we don't need to pass value for account ID while calling the constructor. Hence, in testaccount.java, we are passing only one parameter, that is, account balance. Let us recall what static does. As we already know, static creates only single copy of attribute in memory, which is shared across different objects. So, here only single copy of counter is created, which is shared by all objects of account class. So every time a new account object is created, the counter gets incremented. Therefore static variables are class variables, and not instance variables. And static variables belong to class, and not to any instance, or object of that class in particular. Now let us assume that we want to know the name of the bank. Now this information is not dependent on any kind of account information or instance of account. Similarly, when we want to have a method that is not dependent on any attribute value of object, then we can make such method as a static. As shown in example, we want to display bank name, where it is not related to any account object in particular. In general, common utility methods are created as static. We can have showBankName as a static method. As functionality of showBankName is to print the name of the bank, irrespective of account object in particular. That's all, folks.